slingshot equation number 1. Negative 16t squared plus 27.94t plus 1. Negative 16 is the gravity coefficient, 27.94 is the initial velocity or distance equals to speed divided by time, and 1 is the initial height.
This chart shows you the domain, range, vertex, roots, y-intercept, and gravity coefficient of launch number 1.
To find the vertex of this equation, we had to complete the square. And with doing that, we figured out the vertex. To figure out how long the pumpkin was in the air, we had to solve for t. With that, we figured it out.
A pattern of change that appears through all of the graphs and tables is that as time increases, as does the height of the flying pumpkin. Inversely, a pattern of change that appears in the graphs and tables is that as at the max or the vertex, as time increases, the height of the pumpkin decreases.
The equation for slingshot number 2 is negative 16t squared plus 26.11t plus 1. Negative 16t squared is the gravity coefficient, 26.11 is the speed, which is distance over time, and 1 is the initial height. Here you can see the domain, range, vertex, roots, y-intercept, and gravity coefficient of launch number 2. In this equation, we found the vertex by completing the square. We found out how long the pumpkin was in the air by finding t.
For slingshot number 3, the equation is negative 16t squared plus 98.11t plus 1. Negative 16 being the gravity coefficient, 98.11 being the velocity, which is distance over time, and 1 being the original height, or starting height.
This chart shows you the domain, range, vertex, roots, y-intercept, and gravity coefficient of launch number 3. We found out the vertex by completing the square. Finding t helped us calculate how long the pumpkin was in the air.
For dropping number 1, the equation is negative 16t squared plus 13.3. Negative 16 being the gravity coefficient, and 13.3 being the starting height of the pumpkin.
In this chart, you can tell the domain, range, vertex, root, y-intercept, and the gravity coefficient of dropping number 1. We found the vertex by completing the square. We found t to tell how long the pumpkin was in the air.
For dropping number 2, the equation is negative 16t squared plus 13.0. This is because negative 16 is the gravity coefficient and 13 is the starting height of the pumpkin.
Above you can see the domain, range, vertex, roots, y-intercept, and the gravity coefficient of dropping number 2. Here is our work for finding the vertex. Here is our work for finding t.
The equation for distance dropping number 3 is negative 16t squared plus 13.6. And so negative 16 is the gravity coefficient and 13.6 is the initial height. Here is the domain, range, vertex, root, y-intercept, and gravity coefficient.
Here's our work for finding the vertex. Here's our work to show how long it took the pumpkin to hit the ground.